So 1b, moving on in the chapter to the next part, is distance time graphs. All that means is we should be able to, one, draw a graph that represents or tells us what is the distance traveled by an object in a certain time, or they give us the graph in the exam and we actually just have to interpret the data. We have to look at the graph and say, okay, can I take the important information from the graph and actually answer a question? So distance time graph just means distance goes on the y-axis, so the distance traveled is on the y and time is on the x. They may give it you in kilometers, meters, it could be in miles, it depends on the day. And then the time can be in all sorts of different units. It could be in seconds, it could be in minutes, hours, it could be in days. And they will give you a graph or they will ask you to draw one. Now all we need to do to interpret this is just look at the starting line is a straight line increasing, so the distance increases from 0 to 5, it's in kilometers, so it goes from 0 to 5 kilometers in from 7 to 7:15. Alright, so this basically says they've traveled 5 kilometers in 15 minutes. And then what happens is it actually changes the slope, so it gets a bit steeper. So if we remember from math, the gradient is the steepness or the slope of the graph. So this one is clearly a little bit steeper than the one before, and we'll find out what that means in a second. But this goes from 5 kilometers to 25 kilometers, so that's a distance traveled of 20 kilometers. But the time was from 7:15 to 7:45. So from 7:15 to 7:45, which is 30 minutes, this object, car, person, has traveled from 5 to 25, which is 20 kilometers. So they traveled 20 kilometers in 30 minutes. But we don't know any direction, we just know how far they traveled. So this is a scalar. All right? This part here, a flat line, so that means no slope. It has a steepness of 0, so the gradient at this part, horizontal, is 0. But this line doesn't move, so if you look, it's at 25 kilometers and it doesn't go anywhere. But time is still ticking, because obviously time has to continue. So what this means is they've traveled no distance, they're still at 25 kilometers, but they don't move anywhere else from 5:45, and every block on here, what have we got, from 45 to 6. So it's actually about 7.5 minutes. So in 7.5 minutes they don't travel anywhere. So 0 distance in 7.5 minutes. Then what happens is from 25 they come all the way back to 0 meters. Okay, so they travel a distance from 25 back to 0, which is still a 25 kilometer distance, but obviously it's coming back to 0, which means they're probably going home, so they're going back to where they started. So from 25 back to 0 meters, and that went from 17:45 and the 7.5 minutes there, so 17:52.5 to 8:15. So that takes 15 minutes plus the 7.5, so about 22.5 minutes to get 25 kilometers. And that's how you interpret the graph. Just take every section. You can see I've actually labeled it A, B, C, D, because there's 4 different journeys. Journey number 1 was from there to there, then it changed. So they went from there to there in a steeper gradient. They didn't move there, that's another section, and then they went all the way back from 25 back to 0 in that time. That's how you actually interpret a distance time graph. But what we can take from that is how far this object goes in a certain time is the steepness. So the steeper the graph, the further this person or object goes in a shorter time. Now what that means is the gradient of a distance time graph is the speed. Now in maths, you've probably heard the gradient as the rise over the run. So if I just draw on this graph quickly, if I want to find the rise over the run, let's take section A. I'll put a little dotted line there. The rise is the change on the y-axis, but it's section A, and then it has a new gradient, a new steepness for section B. So I'd have to find the rise over the run, the gradient separately for those 2 sections. The first one rises from 0 to 5, so the rise is just 5 kilometers, and the run, which is the change in the x value, is 17 to 17, so it's 15 minutes. So if I just put 15 minutes there, I have a rise of 5 and a run of 15 minutes. Now, if I want to find the speed, I do the rise divided by the run. This one is a little bit tricky, because if I wanted to give a speed, then a unit for speed, as we said, was meters per second. So I have kilometers and I have minutes. Or I could give kilometers per hour, or I could give miles per hour. So I need to know, first of all, what does the exam want from me? I have to check what the exam wants. But in this case, if it lets you choose your own unit, you might do kilometers per hour. Now, because I've got 15 minutes, because this is in time, then to turn minutes into hours, you have to do divide by 60. So this one would be 15 divided by 60. Now, 15 minutes out of an hour is a quarter of an hour, so it's 0.25, okay? So the time is technically 0.25 hours. So then what I do is I would do 5 divided by 0.25, so the gradient is the rise divided by the run. 5 divided by 0.25, which would be 20 kilometers per hour. So the speed for section A only would be 20 kilometers per hour, okay? So if I want to use a distance time graph, the gradient of a distance time graph is the speed. Do the rise over the run for the section that they asked for in the exam, okay? The only other thing to note here is this one has a different gradient. You'd have to do the rise over the run for this section. This one doesn't travel any distance in the time. So if it's flat and horizontal on a distance time graph, it means that the speed is 0, because there's no gradient. If it's flat, there's no slope, there's no steepness, which means the gradient is 0. So the speed of an object that doesn't move is 0. Okay? So to find the speed from a distance time graph, you have to do the rise over the run. Now what we can do is actually turn that into an equation. So the speed equals the distance divided by the time. That's the first equation that you have to remember for the GCSE physics. So speed equals distance divided by time. You have to remember it, you have to be able to use it, and you may be expected to rearrange it. So if I rearrange this equation, speed equals distance divided by time, and I've been asked for distance, I might circle the one that they asked me for, and then I need to take the time and I will move it to the top on the other side. Because time is on the bottom on this side, it gets multiplied to the top on the other side. So distance, I'm just going to put the symbols, equals speed times time, okay? So if I want distance, time is on the bottom, I move that by multiplying to the top on the other side. If, for example, they actually ask me for, let's rub that out, they ask me for the time. So time is what they've asked for this time in my equation. I write the equation that I remember, speed equals distance divided by time. They've asked me for time, so I do the same thing. I take the time to the top like I did before, because it's on the bottom and I need it on the top. So I take it to the top on the other side, so it's times by time. But then I don't need speed on this side because I'm looking for time. So if I still circle the one I'm looking for, speed is the one that I now need to move. I will take this and I will move it to the bottom on this side. Because this is on the top and it's times, I take it to the bottom on the other side, which is divide. And in maths, when we're rearranging equations, we always do the opposite to what we have. So this was divide, I timesed it to the top. Now I need t on its own. This one is times, so I divide it to the bottom. So time equals distance divided by speed. You may be expected to rearrange those in the exam. It depends what they ask for. And I would always say, write the equation that you remember, then circle the one that they've asked for, then rearrange it correctly. And that's already 1 or 2 marks in the question without even doing the calculation itself. All right, so that's how we do distance time graphs and how we find the speed from a distance time graph, either using the gradient or using the equation.